Okay, we're live here with Pete. Hello, people. I hope that you can see the screen of Pete. My name is Milen, one of your hosts. We're expecting Peo to join us in a second. He's finishing the presentation with Jacobus. And just want to remind you that after this presentation, there is a 1 hour break for networking. And I hope to meet you for the discussion panel after the longer break. Peo is here. Peo, Pete, the stage is yours. Good luck.
Thank you, Milan. Good to see you, Pete.
Hi.
And actually, I'm now at this point, I'm really, really sorry that this thing is virtual. Pete, let me just start with, we have basically everybody who, I know that contributed meaningful to FIBO, present. We have Eliza, we have Dean, we have Dennis, David Newman is here, Jakubus, Kevin, all-star meeting. I very much apologies if I missed somebody because I've been browsing the attendee list. And you are to present the practical ontology and development of the legal entity data sets. And I'm very grateful for your work. I'm a heavy user and a fan of your efforts. And I deeply, deeply appreciate everything that you do and continue doing on this. Let me reassure you, your efforts are key and foundational. So thank you again in public. And please let us know where this thing is going. I'm really thrilled to have you here.
Okay, thanks, Peo. Good morning or evening, everyone, depending on where you are. I'm in California now, despite my English accent. So I've been doing modeling for a long time, not only ontology modeling, but enterprise modeling, software modeling. Like Kevin, Kevin was on the OMG architecture board. I still am on the OMG architecture board, and dealing with standards related to bringing together the worlds of more traditional modeling and ontology modeling. So I've been involved with standards like MOF and ontology definition meta model, and then bringing the two together with a standard called MOF-RDF. As Peo said, I've also been involved with FIBO since pretty much the start. And also, I'm now working with Agnos.ai, who you just heard from our CEO, Jacobus. And also, again, with Jacobus and Dennis and others, we recently, in the last year or so, started EKGF, the Enterprise Knowledge Graph Foundation, which I'll start off, I'll say a bit about at the start of the presentation. But what this presentation really is about real practical ontology development and using ontologies for real enterprise data in a real scalable way. And I'll talk about some of the aspects involved in that. So I'll talk a bit about EKGF and then the background of legal entity identifiers and GLEIF and what this is all about and what's it for. Then I'll look at the data that Glyph has been publishing already in XML format, and then look at the real practical approach I took on this project to represent the Glyph data using ontologies and RDF. So I'll look at both the ontology modeling and the data modeling, and then look at where we are now and further work. So the Enterprise Knowledge Graph Foundation then, just briefly, so what we're really trying to do with the EKGF is really act as a springboard for everyone doing initiatives or products or deployments for enterprise knowledge graphs. So I won't say too much more about it because Jacobus covered the idea of an enterprise knowledge graph. So it's really about taking the ideas of knowledge graph and ontologies and RDF and applying them for real business value in an enterprise-wide manner, not just for single projects. So what we're trying to do is adopt and encourage the adoption of standards. Jacobus talked quite a bit about the maturity model, so I won't say any more about that. But we're aiming to curate a repository of reusable use cases, models, ontologies, which are really suitable for enterprise usage. And then build a community around that and the advocacy around that to help both vendors and people working within the organization and consultancies and academics sort of make the business case for EKG adoption and the practical steps people can take. So we've got a few founding members. I'm sure you'll recognize a lot of the names here, including Ontotext, of course, Accenture, who you heard from yesterday. Agnos, you've heard from already. And you've got Cambridge Semantics, Data.world, who are very relevant for this work that I'm going to be talking about here. So a bit about the project then. What is Legal Entity Identifier? So it was introduced after the financial crisis in 2008, where people couldn't work out who they were exposed to through various financial contracts. So the problem was they just referred to companies by name, and the lots of variations of name, and it was really hard to tie all those different names together into knowing who exactly they were dealing with. And then in terms of exposure, who did those other companies own and who owned them? Because if the parent company dies, and that parent company owns 6 or so other companies that you're dealing with, then you're going to be exposed, even though you haven't got a direct contact with the parent company through these ownership relationships. So this whole idea of a unique, verifiable identifier for each legal entity that you have a financial contract with was introduced as a worldwide initiative. And there's a whole bunch of local operating units where people can register their entities and get a legal entity identifier, and then renew them every year. And then they're coordinated by GLEIF, the Global Legal Entity Identifier Foundation, which publishes the combined output from all these local operating units. So the local operating units could be like a company register, it could be that, for example, the London Stock Exchange is a local operating unit. Bloomberg is also a local operating unit. So it's a whole bunch of people, and you can pick and choose which one you want to register with, but they're all brought together in a single published source from GLEIF. So up until recently, they've published this information not only on their website. You can go to glyph.org and search for any legal entity, but by name or by legal entity identifier. They also publish a downloadable XML form. In fact, they publish it in a few different flavors, including one they call a golden copy, which they publish 3 times a day. So this is, there's 2 main parts to the legal entity identifier information. So it's not only the legal entity identifier, but it's all the information, important information about the legal entity. So what is its legal name? Where is it registered? Where can you find out information about it? Like on a local business registrar, for example, in California, all businesses have to register with the state of California. So the legal entity registry will say, okay, what's the registered ID for that entity, and in which who's the registrar for that. And there's address information, pretty much all information you want to know about an organization you might want to deal with. So this is the level, what's called the level 1 data, who is who. And then the level 2 data is who owns whom. And this is really about establishing the exposure. So this is in the XML, you've got a record for each relationship, and there's different types of relationship, like a direct parent and also an ultimate parent. And then you can see the sort of graph that you can construct on the right there, where you've got child entities and the parent entities. So you can build together a whole tree structure of the legal entities. There's a few sets of ancillary data. One is for entity legal forms. This says, based on the jurisdiction, what are the types of legal form? For example, GmbH in Germany, LLC in the US, publicly limited company in the UK. So there's a huge, quite a surprisingly large number of different legal forms. And there's an ISO standard for that, and GLEIF happens to be the registration authority for that as well. There, in fact, is a register of registration authorities. So I mentioned earlier that in California, the state of California is the registration authority for anyone setting up a business in California. So there's actually a register of those, so you can find out where to look to find out if something's a valid company or not. Another minor thing that GLEIF publishes is there's some exception reports. If you're not reporting your parent, you need to say why. Maybe you haven't got a parent, or maybe there might be legal reasons you haven't got a parent, or maybe the parent might be a private individual who owns the company, who's not required to report their information. So what are we trying to do with this project? So this is a project instituted by GLEIF. I was the lead ontologist on it, and I was working with data.world, which you'll hear about later, in terms of actually publishing the results and helping verify the ontology. So I worked with people like Dean Alamang and Brian Jacob on that. So firstly, we're looking for a semantic representation for the GLEIF data, i.e. not only as an XML schema and an XML dataset, but an OWL ontology and an RDF dataset. But we do want to keep it reasonably familiar to existing users of the XML. So we didn't want to just totally turn it upside down and inside out, so people familiar with one wouldn't have a clue about the other. We are separately publishing the OWL ontologies from the data. We're allowing semantic validation and querying. We want to allow people to do inferencing across the information, but we also want to allow people to take the RDF data and use it in a more traditional triple store, which might not have an inferencing capability. We want to allow the data to be downloadable in bulk, just as the XML is available in bulk, but we want to take advantage of the capabilities of RDF and Sparkle and make the data dynamically accessible across the web. And we want to support linked open data, so everything will have a URI, and you can link to it, you can traverse it, you can include it in open scalable queries. And obey the FAIR principles: findable, accessible, interoperable, and reusable for good data sets, which can be linked with other data sets and managed as part of make this whole data set a reference data set. And we want to make it scalable, a scalable representation. So there's currently just under 2 million LEIs and rapidly growing, and GLEIF itself has plans to make it grow even more rapidly. We want the set to be regularly updated and the whole thing to be open source. So that's what we're trying to do with the project. So now going to my own opinions. So this is a health warning for what's to come. This is my own pragmatic advice, reflected in how I went about modeling the ontologies and the data. And they represent a pragmatic rather than a theoretical approach, bearing in mind the aims of enterprise scalability, practical maintenance, making the data consistent and predictable, and also familiar to people who are used to the XML. And the general approach I think, is very suitable for people being able to import and make use of any legacy data, because as Jacobus mentioned, people aren't going to start from scratch and use RDF in isolation. They're going to want to link to existing data sources either dynamically or through a bulk load. So looking at the ontology approach, can I just, there's a question here about changing the slides. Are people, I hope people, let me know in the chat if they're not seeing the slide ontology.
I believe you're okay.
Okay, thanks. So how do you go about developing an ontology to represent enterprise data? So my actual approach is to not start with an information model or whatever, an XML schema or whatever, but actually start with actual data, start with representing the real information. For example, as a set of sample triples, or as a set of diagrams, the sort of graphs you've seen earlier of the actual instance data. In this case, the real legal entities, the real relationships between them. That I find really helps ensure that your ontology is adequate for representing the data. And it's also great for working with business users to help understanding and again, help to ensure that the ontology is adequate for representing the data and it makes sense to the business people. And working with business people with real data, I think, is a lot more practical and amenable to them than trying to represent data models, or even worse, sort of more complex ontology models with lots of restrictions and so on. Also, working with real data helps resolve multiplicity issues, like how many individuals, how many objects, if you like, do you need to represent one real world situation? One practical example is around if you're trying to represent employers and employees. If you're trying to represent the employer role, if you've got a big organization like Bank of America, for example, that employs many thousands of people, if you want to represent, it's fairly straightforward. You'd represent the employee role as a single individual, a single resource. But for the employer role, Bank of America as the employer of several thousands of people, do you represent that employer role with just one individual linked to all the employees? Or do you have a separate employer role for each employee? So you'd end up with thousands of employer roles for Bank of America. And if you just work at the ontology level, you might have an employer class and you might have an employee class, but that doesn't really tell you practically, would you have one employer individual or many employer individuals for the Bank of America situation I mentioned. The other benefit of taking a data-driven approach is it allows you to use the best practices of test-driven development, which people use frequently for software. So you ensure that as you develop the ontology, it remains valid with the test data, the examples that you're starting with. And that's important for reasoner-based consistency checking. If you're developing in something using a tool like Protégé with a reasoner that helps ensure the ontology is consistent, often you only find consistency problems once you bring in the real instance data. The ontology, just looking at the ontology, the OWL itself, the classes and the properties, doesn't always reveal inconsistencies. Second main ontology approach is to be very ruthless. Be ruthless both about scope and very much, as Jacobus said, very much have your project, your EKG driven by use cases. And associated with use cases are competency questions. So what are the questions you want to be able to ask about your data through the ontology? And the obvious of that is don't include an aspect just because you can, or that you might have some data in a legacy database which you could easily represent in ontology or in RDF. The advice is not to include it just because you can, or just because it exists out in the world. The danger is you get excited about developing ontology and you end up trying to boil the ocean and just stuff everything in there just because it's fun and because you can, not because it has a real purpose or there's a benefit with actually maintaining that. Because the more you add in, the more clutter, the more people have to understand and get to the bottom of and have to map from legacy data sources. The other thing to be ruthless about is abstraction. It's, again, very tempting to put in lots of high-level classes and superclasses, but as I'll go on to say, in an ontology, you can have super properties as well, and a set of higher-level properties. So you need to be ruthless about asking yourself, will this class or property ever be useful in a query? And also, I'd say be focused about the real data and the real usage, and don't be swayed about what might look neat or easier to manage in your development tooling like Protégé. In Protégé, it's easier to manage if you've got a nice, neat class hierarchy. But I'd say don't be swayed by that. You don't need to have a nice, neat class hierarchy for practical purposes for your enterprise ontology and your enterprise data. Another key thing to remember when developing an ontology is an ontology is logic, not an object model. So a number of people do try to use UML or entity relationship modeling semantics rather than remembering the semantics of the environment that you're working with, which is an ontology or RDF environment. And here's some particular pitfalls that you can hit. One of them is people use domain and range of a property, or domain and range is like a source and a target of a property, to represent a constraint rather than an inference, which is in fact what it is for. So if you take an example here where you've got a property employees with a domain of company and a range of person. So people often model that as an arrow, if you like, from company to person, saying company employs person. So if you combine that with an actual instance, you create an instance called Pete and say they're an instance of the class person. If you then, in addition, say Pete employs John, a lot of people might say, well, that's an error. You can't have Pete employing someone because Pete is not a company, because we said that the domain or the source of employees is a company on the first line there. However, that's not an error. What, in fact, in an RDF environment will happen is that because you've said the domain of employees is a company, you'll end up with an inference that Pete is a company. So that's an example of where an ontology, an RDF environment, differs from a more traditional UML or entity relationship environment. It's not a constraint. There are other ways of doing constraints, but it's not through domain and range of a property. The other thing to bear in mind is that, and I think you can get a lot of value by taking advantage of, is that properties themselves are not just attached to a class as they are in a traditional object-oriented approach, but they're reusable first-class items with their own hierarchy. I'll show a quick example of that. This is actually from the Glyph ontology. This is a property hierarchy for addresses. So the property is has address, and it's we've got it as the range of so the domain of this is entity, and so you can see an address is we're not showing the range here. The range is a physical address. Sorry, yes, here's the range, physical address. So you've got the class here, physical address, you've got a class entity, and has address is the property. And there's various sub-properties, there's various nuances and different types of has address. There's a geocoded address, there's a legal address, which is a type of address, there's a headquarters address, there's a transliterated address. And you can see there's a whole hierarchy of properties here, which people are not familiar with if they're used to an object-oriented or entity relationship environment. And the benefit of this is you can say for an entity, get all the addresses, and it will get the whole set of addresses, including the headquarters address, the legal address, and so on. Or you could ask specifically, I just want the legal address. Or you could ask specifically, I want the transliterated legal address. So the same approach you take with classes and subclasses, you can get a lot of value for properties too. So going back to the other aspects of logic, with object orientation, an individual has a single class only, but in an ontology, an individual can have multiple classes. And there's an example you can see here. Pete is both a person and a company in this example. Also, individuals may have multiple URIs or identities. There's no unique names assumption unless you constrain them to the entities to be different or disjoint. So the thing with the URI of Pete and the thing with the URI John may refer to the same things unless you say otherwise. The other important thing to remember in terms of logic is there's no negation as failure. Just because something is not explicitly represented doesn't mean it's false. So we don't have a fact saying John is a company. It may or may not be true. If you create a query, you can't assume that John is not a company. Now, if you want closed world, if you want the fact that you haven't got an assertion saying John is a company to imply that John is not a company, then you can use shackle for constraint language and close the world. So we looked at that. Next thing I want to talk about in terms of practical advice is definitions. So not only consider the logic, but include natural language definitions. Kevin mentioned this earlier when he was talking about ontologies and mapping things. So the natural language definition ties the logic to the real world. And the thing to do when creating the definitions is terms used in the definitions are actually consistent with the ontology, and focus on the meaning, not the names. And for example, an example of getting confused by the meaning is you have the English language term fixed income security, but in fact, the way that's used in English, it may actually be used for variable rate bonds, which is not fixed income. So beware of getting tied into the name, focus on the meaning. And don't base your constraints on a name. And if you want to use the common terms, include them as synonyms. Another advice is keep the definitions clean and simple and use separate properties for explanations and examples. And avoid being too clever with your own annotation properties. Try to keep with the simple annotation properties like IDFS label and IDFS comment, because if you don't, then the tools you use or someone trying to use your ontology might not end up displaying them or supporting them. There's a few modeling dilemmas here. I won't spend too much time going through because the time is short. There's a bunch of pragmatics. Generally, for ontologies, try to choose things, not strings. Generally, start with the data as individuals and try to model up from the individuals you want to represent. And avoid classes except where you want to really do classification. And avoid including classes in triples themselves, because then you end up with a thing called punning, which can cause problems with reasoners and reuse. So if you do end up trying to create relationships to what might be a class, instead of a class, consider individuals of a generic class such as category. So if you've got different types of bank account, for example, that may be better as a category rather than as a class. And there's a few hard problems which generally there's no easy answer to. You need to just think through the pragmatic problems and always remember the use cases and the sort of queries you want to do. So one example I mentioned earlier was, do you want to verify a role such as employee and employer, or is representing a verified relationship, i.e. employment, sufficient? So in one case, you have a single relationship linking the company and the person. In the role case, you end up with two things, or maybe three things linking a company and a person. So generally, I'll advise use a simpler verified relationship unless there are specific properties that apply to the role. And if you do have roles, specify how many individuals, as in the example I gave earlier about Bank of America. General problems is if you try to represent temporal properties that apply only for a time period. For example, do you really care that a name, Bank of America, only has had that name for a certain number of years, and before that it was a different name because it was taken over and a merger of many other previous companies. If you don't really need the temporality, then don't get into it because it can lead to lots of problems. And use of inverses can be convenient for business naming, but in generally they're not logically needed, and they add a level of ambiguity in that if you're trying to represent actual data, then do you represent it in the forward direction or the reverse direction, and do you query it in the forward direction or the reverse direction? And if you haven't got reasoning support, then you can end up with difficulties. So that's some rules of thumb which I've developed over the years and have applied for the legal entity data. And these are just some generalizations for that when doing ontologies within an enterprise. And the general thing to remember is that there's a lot of flexibility with ontologies. So don't sweat one perfect ontology. RDF is designed to adapt and evolve both ontologies and data. And in the same way that light you can treat as a particle or a wave, you don't necessarily need one ontology. You can have different ontologies for different sets of use cases. And don't use a more complex ontology than you need. For example, you don't need, in a physics environment, you don't need Einsteinian equations for working out how long a ball you drop will take to fall. You only need Einsteinian equations for interplanetary gravity, not for local gravity, when fairly simple equations like height and the acceleration of gravity will suffice. So you can also have bring together different ontologies and mapping. So, for example, FIBO, as mentioned earlier, is a very complex, sophisticated ontology. What I created for GLEIF was a far simpler ontology. And there's you can use capabilities to map them together. Here's an example. You can use equivalent class relations. There's same as capabilities for different individuals. And then there's also equivalent properties and sub-properties that you can use to map different ontologies together. So you can have different ontologies representing the same data, different views for different purposes. So for the data approach, I'll go through this fairly briefly. There's really think about the scalability and think about the ability to process the data. And if you're processing a lot of data, then really think about how can you process it to allow for streaming of the data and parallel processing. And also consider the URIs you assign to allow future refreshes of the same information. For example, the GLEIF data is refreshed multiple times a day. So you need to be able to assure that each time you've got the same URI for the same legal entity and for other aspects to it, like its address and so on. So that's a whistle-stop tour of what we've, the approach I've taken for the GLEIF data. So the GLEIF ontology has been approved and announced by GLEIF, and you've got the links here, which you can link to. And the ontologies themselves are available online, both as RDF and HTML, and you can see the links here. And you can, in fact, link to each individual property, such as has legal form, and that will link to a web page describing that. We've got the ontologies themselves available in a directory, linked open vocabularies. And the ontologies and data themselves are available at data.world. And there's a data set here I've linked to. And if you look in the chat, Jeff Braswell from GLEIF has linked to the pages as well. And what you can do with the data there's some example queries. You can download the data as RDF. You can query the data online. There's some example Sparkle queries. You can use a Sparkle endpoint from your own local environment using the service keyword. So you can have unified queries that bring together any data set you like. Or you can directly access, you can follow your nose and use HTTP to use access for the data and get a reasonable set of data back. So we've got with data.world, we've got a Docker-based process in place that will, at the moment, update the data on the GLEIF, on the data.world website weekly. That we could change that. But currently it's updated weekly, and the metadata associated with it will tell you when it was last updated. So finally, further work. So this is still a work in progress. We're going to do more work around publishing the ontologies and the data and how to use it in the benefits. And we want to build case studies, especially integration with other data sets. So if people have used it already, please let us know, and we'll help publicize it and get the word out. And we're already talking to both MetaFacts and Ontotext to get some user-friendly tooling demonstrators on board, showcasing both the data and the practical use of it, and also their own tooling, some of which you've seen already in this conference. We're going to be updating the ontology of data to reflect forthcoming changes in GLEIF, just to reflect business changes. We are going to be open sourcing the full code for the transformations, the ontologies that are already out there. And we're going to do further outreach and integration and really position what we have here as a reference data set that other people can link to and build into their own solutions. And then use for work to springboard a community. So everyone who wants to talk to us around this, we want to springboard a community for enterprise best practices, curation and automation, and create a community site for that, not only at data.world, but especially around the ontology side of things at ekgf.org, and around some of the pragmatics and guidelines I've been talking about today. We want to build up the set of best practices and involve other people's advice, not just mine. Okay, that's all I have. Sorry, I went on a bit longer. Luckily, I'm the last session, so we can open it up to any questions.
Thank you very much, Pete. This is key and foundational. Again, I really enjoy working with the data, and yep, recently, like really soon, what we have like an internal data set, we are going to expose it like publicly. So if anybody is willing to discuss what would be the best case to showcase your work and of course the tooling, please reach out. I'll be very interested in this discussion. So the questions, actually there are a lot of questions around the actual ontology. Yes, it's public. Kudos to DataWorld and Bright in particular for ensuring the architecture. They have made it really easy.
And it's actually quite well enabled for SEO. So if you just search for Glyph ontology, you'll probably find one of the HTML renditions of the ontology, the documentation we published.
Yeah, it comes first. So apology if I miss. I don't see actually clear question in the comments. But the what you see as the further work sounds excellent. So best of luck with the efforts, and we will try to help to the best extent possible. Again, this is very, very helpful data set, and I wish more and more attributes to the data to make more use of it. And let me know who should ask to make the L2 reporting not optional. Like this would make it really good data.
And there's also other data sets it's already linked to. There's a data set I'm involved with creating at OMG. It's called LCC for Languages, Countries and Codes. There's a complete ontology and set of RDF representing all the country codes and region codes that ISO publishes. We converted that to an RDF data set that is on the OMG website. It's also loaded into data.world for convenience. And again, that's all available. And some of the example queries already on that data.world site link to that data set already. So we're taking our own medicine with respect to reusing stuff that's already there.
Actually, it works smooth. Like I really enjoy because most of the addresses are geocoded and everything refers to the LCC dataset. So it's perfect usability. Now with the mappings, one is able to load FIBO, GLEIF, and LCC in one dataset, and you have basically the best of ontologies and the best of the reference dataset in one place. Which is
so I'm looking forward to extending that still further to Wikidata, sort of building on some of the demos we saw earlier.
And I see Marcel here from Essence is commenting, like if you would like to do a playground group for linking the records from the Glyph entities to Wikidata, this would be something which I'll be very interested to participate. Although that, I have a lot to share. We have thought about this one. They are loaded in closed repos. They are not properly linked. So Marcel,
there's also open corporates who publish a whole bunch of data, which would be good to link into. There's a Refinitiv publish a bunch of data with their own perm ID. So this is really getting exciting, and I think as a community,
they unfortunately have stopped publishing their data set, but Refinitiv, their reference data is already enriched with the Glyph identifier. So it's really, yeah, it's a quick win. Let me see, just because I like not to overlook the chat. Nada is asking to evaluate the ontology. Can you see the question? Is there a way to evaluate the ontology other than the CQs, queries, and reasoners?
I'm not sure what that means to. So you can load it into Protégé. It's consistent, and likewise you can do any extensions in that. It's all downloadable and available. The ontology is available today.
And the HTML version also public, like in the URLs that have been published in the chat. Jeff, new relationship types. Okay, this yeah, I would be happy to learn more. Like Pete, if you can tease us, because Jeff has not access to the mic. Sorry, Jeff. I'll be interested to learn. So
yes, at the moment in the Glyph data, the relationship between an umbrella fund and the individual funds is a direct property. In the next version of the Glyph data, that will be modeled in a similar way to the parent-child relationships that I showed you earlier. So that's just a more general way of representing the relationships. And there's a few other things that are changing, like representing government entities in the new version of the Glyph data. But there's a few other things which. So the changes have already been published by the Glyph in the XML version. So you can go to the Glyph site already and look at that. Over the next few weeks, we'll be working on the ontology version of that.
Okay, this is interesting. We looked in for the updates of the ontologies, because I haven't updated in quite a while, and I just update the data sets.
So, and Eliza, so they're not there yet.
Eliza has pointed out that FIBO actually has a much detailed way of modeling the relationship, which I enjoy. And they also refer to the consolidation relationship of the GLEIF. So if you need more details, FIBO is the way to get really comprehensive view of the abilities.
And Ruth, the mapping I mentioned earlier that we'll be publishing.
The mapping.
I showed a little snippet of the mapping, but there's a full mapping available also.
Okay, Jeff, thank you for the specifications. Well, I can talk about the topic a lot. If you have further questions, now it's the pause of the expo, and I would encourage you to go to the what is referred to as the expo, where there are booths of the different presenters. There are also the capabilities of connect directly through the platform, so you have some chance to reach out and continue the discussions. But Pete, thank you very much again for the key foundational work, the presentation, and basically you've been one of the greatest people to work with. So thank you for being.
Thank you. Yeah, contact me if you've got any questions about this, and anything you'd like to add, anything you'd like to demonstrate, or if you've got your own ontology and you want advice on that, independent of the Glyph stuff, I'm happy to advise. And
I can only highly recommend you. Good. Everybody, there is a expo pause, and it would, after this, there would be the discussion panel where the topic would be delivering and scaling knowledge graph solutions. I hope it would be a great discussion, actually looking at the participants, all the chances that it's going to be really fun and informative discussion. So looking to see you around. Bye, Pete. Thank you again.
Thank you. Bye.